Welcome to the class, dear children. In today's lecture, I am going to explain you about the introduction to graphs. This is the 8th chapter in this is the 15th chapter in NCERT textbook. So now I want to express about the what do you mean by the graphs and why to express the graphs now. So whatever the numerical information we give, that numerical information, if we express that by using a pictorial representation, then it will be easy for us to understand. For example, let us see now. Suppose there are 10 balls in which 5 red, 2 green, 3 yellow. I have explained in the text. Now, if I draw that as out of 10 balls, I have 5 red like this in red color, 2 green and 3 yellow. So now the time the information which has given us in the text, it takes a little more time, but when you see the figure, it will be very clear and you will get the clarity more when compared to the text. So that's why pictorial representation of the numerical data we are now doing. So let us now, how many methods are there? In your syllabus, the methods are bar graph. You can express the given numerical data as in the bar graph. Similarly, pie graph, and then histogram, and the line graph. These are the methods you have. So now let us understand what is meant by the bar graph. So whenever you draw the graph, first you have to understand that there is an x-axis and there is a y-axis. X-axis gives you the horizontal, x-axis expresses on the horizontal line, y-axis represent on the y-axis represents the vertical line. Okay. So now this is the x-axis, this is the x-axis, and this is the y-axis. Okay. Now on the x-axis, this is the test of so and so student. One particular student is given, suppose. Now here the first test, the second test, and the third test. And here the marks on the y-axis is been represented. So 10, 20, 30, 40, 50 as a scale. So what is you can understand is this is 0 and this is 5, this is 15, this is 25, 35, 45 and 50. So now in the first test, the student has got how many marks now? The line corresponding to this is 25. So this is 25 marks. Now coming to the second test, how many he has got? 30 marks. And in the third test, the student has got 45 marks. 40 plus 5 and the bar is here. So this is called the representation of the given data by using the bar graph. One more. Now let us have the histogram. Suppose you want to express that about the sales of so and so fruits and how it is on Monday, how it is on Tuesday, how it is. This is what the explanation. So let us see now what is this in the sales in the kgs and what are the fruits here. And there are two types of graphs if you observe. One is the dark one, dark grey color, and this is the light grey color. He has mentioned that the dark grey color is Monday, light green color is Tuesday. That means Monday sale is. So what you can understand from this graph, the x-axis is having all the fruits, y-axis is having all the number of kgs of the fruits. Okay. So now this mango is a fruit which is in the this dark gray color is on Monday. So Monday the sales of the mango fruit is how much? It is corresponding to 15 and this is in between each you have 5 each, correct? So it is like 2.5, that means 17.5 is this now. This is 17.5. That is mango fruit sale is 17.5 kgs on Monday. So on Tuesday the kgs which is sold is 22.5. See, observe here, it is 0, 2.55, 7.5, 10, 12.5, 15, 17.5, 20, 22.5, 25. Like that it is been given. So you can understand by that the apple is on Monday, apple sale is what now? It is 7.5. And on Tuesday, apple sale is 10 kgs. Like that, you can represent the given representation of the numerical representation by using the histogram also like this. Now let us go to the pie chart, another representation. In this, generally what we give is, we give the percentage of the information. The total is 100%, let us say 10% is informative, 10% is 15% is news, sports is 25%, totally half of the portion is for entertainment in our life. So informative is 10%, news is 15%, sports is 25%, and total for entertainment it is given as 50%. So it's very clear to understand, correct, how to represent the given information. Now let us go to the another problem now. So let us have this problem. See here, the table is been given as weight is 40 to 45 kgs. How many persons are there? 4 persons. In between 45 to 50, there are 12 persons. In between 50 to 55, there are 13 persons, 13 people are there. And in between for 55 to 60, there are 6 persons. So you want to express this by using the bar graph, or by using the histogram, let us say. Then how can we define this? By using the histogram. This is the example. Now look at this. So here it gives us that between 40 to 45, 40 to 45, there are 4 people. In between 40 to 45 kg, there are 4 people. 45 to 50, there are 12 people. 50 to 55, there are 12 and 14. In between, how much it is? There is 13 here, right? 8, 9, 10. There is 1 each here, okay? So this 9. And then 55 to 60, there are 6 people. 60 to 65 kgs, there are 5 people. And 70 kgs, there are none here. It is been given nothing. So for 70 kgs, it has not given any information. See, the information is up to 65 only. So this is what the problem explains about. The numerical data you can explain by using the histogram like this. Another example, let us see. Look at this now. This is about the line graph, we say. So the time is on the x-axis and the temperature is on the y-axis, okay? Now, what is the time at 6 a.m.? How much is the temperature? The graph is what? 30, 30, when the mid value is not given. So it is 31, 32, and then 33, 34, like that. So that is the temperature on the y-axis, okay? Now at about 6 a.m., the temperature is 37 degrees. So it is given as 37, okay? At about 10 a.m., the temperature is 40 degrees. About 2 p.m., the temperature is 38 degrees. At 6 p.m., the temperature is 35 degrees. Similarly, the time. So when you draw this graph, the points, we are able to plot the points like this. And then you have to join them by using the line. So this is called as the line graph. Okay. This is another way of representation. Now, let us start the exercise now. Okay. This is exercise 15.1. The following graph shows the temperature of a point in a hospital. So, the temperature of a point in a hospital, recording every hour. So, what was the patient's temperature at 1 p.m.? So, observe here the graph on the x-axis, it is time. On the y-axis, it is showing the temperature. So, now at 1 o'clock, at 1 p.m. So, at 1 o'clock, what is the temperature here? The patient's temperature at 1 p.m. The temperature is given by, see, observe the y-axis. In this y-axis, it is 34, then it is 35. That means in between that, there is a 0.5, correct? That you have to understand by seeing the scale. So, it is understood that at 1 o'clock, the temperature is 36.5. The temperature is 36.5. So, the temperature at this point is at 1 o'clock is this. And what was the patient's temperature? When was the patient's temperature? 38.5. So, where is 38.5? This is 38.5, which is corresponding to this point, correct? Now, this point is corresponding to what? At 12 noon. So, at 12 noon, 38.5 degrees temperature is there. Now, let us see one more question in this. We will understand one more question on this. It was given. the patient's temperature was the same two times during the period given. What were these two times? So temperature was the same in between at the two times. So at 1 o'clock the temperature is 36.5. At 1 o'clock the temperature is 36.5, correct? And at 2 o'clock also the temperature is 36.5. So at these 2 points the line, it is the same. So at 1 p.m. and at 2 p.m. the temperature is the same. So the next question. What was the temperature at 1:30 p.m.? So at 1:30 p.m. that means what? Now here it is at 1:30. So at 1:30 what is the temperature now? How will you say this now? That is the D question here, right? So A, B, C, D question it is. So the point between 1 p.m. and 2 p.m. this is 1:30. At this point it is 1:30, correct? So at this point on the x-axis, how it is now, it represents at what point now? It is actually this point. So at this point it is again 36.5 degrees only. So it is understood, right? So that is 36.5 degrees even at the time 1 and 2 in between it is 1.5. At that means 1 hour 30 minutes. What is the temperature? It is again 36.5 degrees only. So next question is, what was the patient temperature at 1:30 p.m. Next, during which periods did the patient's temperature showed an upward trend? What do you mean by upward trend here? Let us see that one now. The upward trend means what? Upward trend means what? It is from at what time it started increasing. That means from at what time it is increasing. Let us see. At 10 o'clock it started increasing, correct? At 10 o'clock it started increasing. See the graph. And at 11 o'clock it is peak up to 39 degrees centigrade. So from 10 to 11 the graph is upwards. Okay. Similarly, and then the graph is downwards here, correct? And then it is constant here, and then the graph is little upwards here. That means from 2 to 3 again the graph is upwards. So the patient's temperature showed upward when from 9 to 10 a.m. again at from 2 to 3 a.m. Is that clear? The patient's temperature is shown upward trend from 9 to 9 to 11, no, 10 to 11 a.m. Correct? From 10 to 11 a.m. Even 9 to 10 also there is an increase. So 9 to 10 there is increase, 10 to 11 also there is increase. So you can say that 9 to 11 there is increase, upward trend is there. And afterwards it is decreasing like this. Again from 2 to 3 it is increasing. So from 9 to 11 it is the upward trend. Again from 2 to 3 it is the upward trend. I hope it is clear. So this is what the first question. And now let us go to the second question. For an experiment in botany class, there is a problem in that is there are two different plants. Plant A and plant B were grown under similar laboratory conditions. Now their heights were measured at the end of each week for 3 weeks. That means the results are shown by the following graph. So now how it is given? In the beginning, how is that? After the weeks are on the x-axis and on the y-axis these are the heights. Now in the first week the dotted line is plant A and the dark line is plant B. So in the same graph we can represent for plant A and plant B. Now plant A is what actually? This is plant A. This is at the first week. From the beginning to the first week, it has gone to the 2 centimeters height. And from first week to second week, it has grown up to 7 centimeters, correct? And from second week to third week, plant A has been grown up to some, this is 9 centimeters. So this is what you should understand about the growth of the plant by using the graph structure. Now, what are the questions here? Let us see. How high was the plant A after 2 weeks and 3 weeks? So plant A represents the dotted line, right? So after 2 weeks, what is the what is the height? So after 2 weeks, that means here, what is the plant A? It has been increased to, to 9 centimeters height, okay, for plant A. It has gone from how much? 7 centimeters to 9 centimeters. This is the height. It has been grown. That is the first question. Now, in the second week and the third week. So this is what you can say about the graph. And then, how high was the plant B after 2 weeks and after 3 weeks? So after 2 weeks, what about plant B? Plant B after 2 weeks. That means the first week it is this one, after the second week it is this one, and this is the third week, okay. In the second week means this one. In the second week, the plant has been grown from 1 centimeter. This is 1 centimeter, correct? So 1 centimeter to 7 centimeters. And in the third week, it is from 7 centimeters to 10 centimeters. So plant A is, this is the first week, okay? And this is the second week. And this is the third week. In the second week, what is plant A has grown from 1 centimeter to 7 centimeters. And plant B grows from, in the third week, it is plant A goes from this 7 centimeters to, this is what? 9 centimeters. Like that, you can see the line graph and can tell. And then, how much did a plant A grow during the third week? So during the third week, that means from second to third week now, how much the plant A grown in the third week? Plant A, how much it has been grown? It is grown from 7 centimeters to 9 centimeters. Now, how much did plant B grow from at the end of the second week to the end of the third week? By the end of the second week, it is how much it is? 7 centimeters. By the end of the third week, it is 10 centimeters. So this is what you have to see the graph and explain about the questions. And then, how much did plant B grow from then? Okay. During which week did plant A grow most? During which week? Now 0 to 1, the first week it is, there is only a little, 1 centimeter only it has been grown. From first to second week, how much it is grown? From 1 centimeter to 7 centimeters it has been grown. Understood? From 1 centimeter to 7 centimeters. That means there is 6 centimeters it has been grown in the second week. And from 7 to 10 centimeters, that means 3 centimeters it has been grown from in the third week. So in which week it is grown more actually? This is the week. By seeing the observation of the graph also, it is, see here the graph is going upwards. The upward trend is more time it is. So therefore it is the, like this you can answer. Where the two plants of the same height during any week shown here, where the two plants are at a particular week, are they in the same height? Yes, right? In which week it is? If you observe, by the end of the second week, the plant A and plant B are intersecting at this point. So plant A and plant B are of 7 centimeters at the end of the second week. This is what you can say. Whereas in the first week, plant A is 2 centimeters, plant B is 1 centimeter only. So this is what you are understanding by the graph structure. So this is what your second question. Now, the following graph shows the temperature forecast and the actual temperature of the for each of a week. So now, on which days was the forecast temperature same as the actual temperature? Now the days are given, and this is what the temperature. Now this is what dotted lines is the forecast, and actual temperature is the dotted line. So what is the first question? On which days the forecast temperature the same as the actual temperature? At which week it is same as the actual temperature? If you understand, the dotted line and the dark line should intersect at a point. These two. This is the point where it is intersecting. That means on Tuesday, the forecasting of the temperature is also 20 degrees and actual temperature is also 20 degrees. So you have to see where the two lines are intersecting each other. So now if you see here, this is the point where both of them are intersecting. So on Friday, around 15 degrees centigrade, the forecasting is also 15 degrees centigrade and actual also 15 degrees centigrade. And again at this point, that means on Sunday, actually is 35 degrees, even the forecasting is also 35 degrees. So wherever the intersection points are there of these two lines, that you can say that both of them are the same on the actual performance or actual temperature. What was the maximum forecast temperature during the week? Forecast is maximum. That means see the dotted line where it is maximum temperature. The maximum temperature is on Sunday, the 35 degrees centigrade. This is the maximum temperature where you are during the week, which we on Sunday it is more. What was the minimum actual temperature during the week? Actual means dark line. So what is the minimum temperature? The dark line minimum temperature means here it is this one. Where it is more down, it is here. So at this point it is minimum, correct? So at this point also it is the minimum temperature. So that means 15 degrees centigrade on Thursday and Friday also it has maintained 15 degrees centigrade as the actual temperature. Okay. And then on which day did the actual temperature differ the most from the forecast? So differ more from the forecast means you see the distance between this line and this line point. This is just 15 and this is 17.5. So it is 2.5 distance. Now it is nothing. And here it is, the value is here 25 and here it is 30. So 5 centimeters, 5 degrees centigrade difference. And in this now there is 15 degrees centigrade and this is 22.5 degrees centigrade. So this is a bit more when compared to. So the actual temperature and the forecast is maximum. The difference is maximum in this particular distances. So then actual performance differ the most from the forecast temperature means here we can say this one. Here it is more difference it is showing. So this is what the question on the fourth question it is. Now coming to the fifth question. What's the fifth question? You have to draw the lines now. What are the lines here? You have to draw in such a way that for this given graph, given data, you have to draw the graph, linear graph or the line graph you can say. So how will you draw the line graph? Let us see now. See here, that is 2003, 2004 or the years. So let us plot the years here. Let us plot the years on the x-axis. On the x-axis when I plot, let me draw in such a way that, yeah. So here and the years are on the x-axis, that is, let us call this as 203. The year is 203, 2003 and the year is 2004. This is 2004. Let us write 2004 and the year here is 2005 and then here it is 2006. Okay, these are the years he has given, right? 4, 5, 6 and 7 also. 2007. These are the years now. Okay, and now let us number of men and number of women is given as. So suppose if I write number of men and number of women, means men, I draw the men as dotted lines, and women means a dark line. Like that I will draw now. So what is the data given? In the year 2003, it is 12, 12.5, 13, 13.2, 13. So we can see the graph on the y-axis as it is starting from 12 and then 12.5 and then 13 and then 13.5. Let us take the graph like this, so that you will this scale you can do anyway. So in 2003, what is the how many people are there? Men, how many are there? That is 12. So in 2003 it is 12. In 2004 it is 12.5. So it is 12.5. In 2005 it is 13. So it is 13. 2006 it is 13.2, somewhere here 13.2. 2007 it is 13.5. So now this is what the men. So I am wanted to draw the lines as lines, let us say, as the dotted lines. This is what the men's data. Now coming to the women data, that is in 2003 it is 11.3. So that means it is somewhere here lesser, 11.3. In 2004 it is 11.9. That means near. And 2005 it is 13. 13 means here, the same point. And in 2005 and again in 2006 it is 13.2, 13.6. Let us have 13.6 is somewhere outside. And then 2007 it is 12.8. 12.8 means somewhere here. Okay. So now we have wanted to draw the dark line. So 2005 it is how much? 13. So 13 means this one. And then 2006 is 13.6 is this one. And then 2007 is 12.8. 12.8. So you can draw this. So now this is what the men and this is what the women graph. These are the linear graphs we can say. I hope it is clear. Now one more question is there. A counter person circles from a town, a neighboring suburban area to deliver a parcel to a merchant. So his distance from the town to different times is shown by the following graph. So what is the scale taken for the time axis? Scale taken for the time axis. Time axis is what? You can take this as, the time axis is given as 8, 9, 10, 11 like that. And on the y-axis it is the distance in kilometers. So what is the scale taken for the time axis? The scale taken is 1 hour, 1 hour as a gap it has been taken. That means what you can say here is each 4 units is equal to 1 hour. Four units, 1, 2, 3, 4, 4 units is equal to 1 hour. That is what you have to understand. Again 4 units is equal to 1 hour it is. So that is what how much is the scale taken means. And how much time did the person take for the travel. So now how much time did the person take for the travel? The person took how much time for the travel totally? It has taken from, how much time it has taken? It is from, it started at 8 o'clock, 9 o'clock this much distance they have covered, 10 o'clock and 11 o'clock it is this much, and around 11:30 we can say, 11:30 it reached 22 kilometers. So totally the person took how many hours to travel? Totally it is 1, 2, 3, and it is not up to 12, up to 11:30 it is stopped. So 3.5 hours actually taken for travel. And then it was 22 kilometers from the town. How many kilometers from the town it is? See here, how much time did the person take for the travel? How far is the place of the merchant from the town? Totally 22 kilometers from the town. And then did the person stop on his way? Explain. Is he stopped on his way anywhere? No. He has indicated that he writes a first one. It has been indicated that by the horizontal part of the graph, and he stayed from the 10 a.m. to 10:30 a.m. If you see that there is a stop here. That means at 16 kilometers only. Might be he has been started and then he took a at around 11th 10 to 11 in between, right? So here he would have taken some breakfast or something. So at this point, around 16 kilometers of the distance, he has been stopped. So what is the question here? How much time did the person take for the travel totally? How far is the place of the merchant from the town? How far is the place? How far is the place of the merchant from the town? From the town, it is how much distance? It is totally 22 kilometers, correct? And then the next is how much did the person stop on his way? See, he has started traveling, and then he has started again. He is traveling also. Whereas here he stopped when from around 10 o'clock. From 10 to 10:30, you can say. 10 to 10:30, he is totally in the horizontal way. That means only say at the 16 kilometers he is taking rest. So he has stopped at this particular point, you can understand. And during which period did he ride fastest? So the straight line is more, what you can say is more slope it is having at this point. So 8 to 9 is this much, 9 to 10 is this much. 8 to 9 means how much distance covered? Near 10 kilometers. And 9 to 10, how much distance covered? It is 16 and it is 10. So 6 kilometers it is covered. And then 10 to 11 it is covered. How much is the distance? It is only no distance. Only he is taking rest at this time. And around 10:30 to 11:30, you can say he has covered totally 6 kilometers. So where the person has taken more time is 8 to 10. That means from 8 o'clock to 9 o'clock, it has covered most distance. That is the fastest way he has done in this period, actually, during this period. So this is what the explanation about the chapter, the exercise. Now, can there be the time temperature graph here as shown below? Now what is that? Now let us see. So is it the time temperature graph? It shows what it is now. It shows increase in the temperature as the time increases, correct? This graph shows that when the time increases, this is also increasing. Now when the time is increasing, the temperature is decreasing, right? So it is decreasing graph. And then when the time is increasing, time is not increasing. In the same time, the temperature is going up. So that means what it is that since the temperature is increasing very rapidly, which is not possible. So we can say only that one is like this. So it is not possible since the temperature is increasing rapidly at the same time, okay, which is actually not possible, okay. And then what is this shows in the time temperature graph? It shows at this particular point it is the same temperature it is following. So it is constant temperature it is following. So we can say that it is the time temperature graph where it is the constant temperature. The constant temperature means the lines should be parallel to x-axis. Then we say that the constant temperature is this. So up to this I want to explain for today's class. So I hope you are able to understand how to understand the graphs about the given data. You can explain that by using the graphs. So this is what for today's. Thank you, students. If you have any doubt, you please comment in the comment box. Thank you.